Welcome back, this is Willie Breed. I have run the experiment, so just for fun, I'm going to show you the video, one of the videos of the rocket taking off. So here it is. There you go. That's what it looks like when it takes off. I did run all four of the rockets on Tracker, and I found their acceleration over time. This is the Tracker software, and it figures out the acceleration and speed, what have you, basically anything you want about a moving object in a still video frame. So, after I ran it through Tracker and everything, I also put every result for acceleration in an Excel spreadsheet, and these are all the accelerations for each video frame of the rocket. So how Tracker works is you go frame by frame in the video, and you select the object in each frame as it moves. So as it goes frame by frame, I hit the back of the rocket and put a dot on it, and then it showed me what the acceleration of the rocket was at that particular point in time. So then I found the average for each column, so for each launch, this was the average acceleration, and then the average acceleration overall was 2.76. The average acceleration overall was 27.6 meters per second squared. So now we go into here, and the mass of our rocket is held still at 0.062 kilograms. Mass 0.062 kg. And keep in mind that the rocket is also losing weight as it goes up into the atmosphere, because as the engine burns, it loses mass. We're neglecting that, but if we were to actually run this experiment with completely real numbers, we would also factor in air resistance and the fact that it's losing mass as it is going to the atmosphere. So now all we need to do is find the thrust. So remember, force equals mass times acceleration, and our acceleration was 27.6 meters per second. A equals 27.6 meters per second. So we just need to find the force of the thrust, and this is going to be the force of the thrust with gravity factored in. So force equals the mass of 0.062 kilograms times acceleration of 27.6 meters per second squared. 27.6 meters per second per second. So after you factor all that out, that gives you a total thrust. So T equals whopping total of 1.7112 newtons. 1.7112 newtons. That is supposed to be a capital N, and I don't like that 7. So I'm going to erase both of them. 1.7112 newtons. And there you go. Now, I know that the chart told us it would be about 2.2 newtons. That is factoring in, so this is in a perfect world where this takes place. This whole chart takes place in a perfect world. It doesn't factor in, I did it on a little bit of a windy day, which you're not supposed to do. So to factor in wind, because the parachute goes off, the rocket blows around. So if you don't want to lose your rocket, you have to launch it at an angle into the wind. So that angle may not have helped very much. Now keep in mind, two of these launches I did away from the camera, and 2 I did towards the camera. The wind didn't help, and then also there's air resistance that I didn't factor in. All in all, that's pretty close to what the actual chart says. So thank you for watching, and have a nice day.